Okay, Unit 10, Day 2, graphing reciprocal functions. So we've graphed sine, cosine, and tangent. Now we're going to get into graphing cosecant, secant, and cotangent. So if this is the sine graph right there, cosecant is the reciprocal of sine. So wherever sine equals 0, there are asymptotes because you can't divide by 0. And if it's the reciprocal, you're just flipping that fraction. So wherever sine equals 0, we have asymptotes. So there's an asymptote right there at those two zeros and at that 0. Now, this usually goes in. That's just going to go up, and it's going to follow along those asymptotes. So it's really just a bunch of parabolas following along these asymptotes. So there's one parabola, that one goes down, that one goes down right there, and that one goes up. Okay, so that purple graph is the cosecant graph. So the amplitude on cosecant is undefined. We don't have an amplitude. We do have a fake amplitude, but the amplitude itself is undefined. And the period is 2 pi. So my asymptote for the cosecant graph is the period divided by 2. So if my period's 2 pi, divide that by 2, and you get pi. So I'm going to have asymptotes at every pi. So there's one right there. There's one right there. There's one in the middle, and then there's one at 2 pi and at negative 2 pi. And then you go in the middle of those two, so at pi over 2, that's your vertex for that parabola, and that goes up. 3 pi over 2, that parabola goes down. Then those just repeat right there. Okay? For the secant graph, secant is the reciprocal of cosine. So we're really going to set this up the same way. Wherever cosine equals 0, there are asymptotes. So at pi over 2, at negative pi over 2, at 3 pi over 2, and negative 3 pi over 2, there's asymptotes right there. So, same as sine, we're going to just have parabolas that follow along these asymptotes. So there's a parabola right there. That one goes down. That one goes down. Those ones go up. Okay, so we're really just, it's the opposite of the cosine graph. Cosine's all in. Secant is all out. Same with cosecant. Okay, so the blue graph is the secant graph. Again, the amplitude on this is undefined. There's no amplitude because there's no maximum point, there's no minimum point. It goes up and down forever. The period is 2 pi. Now, to find my asymptotes here, I'm going to do my period and I'm going to divide it by 4. So that's going to be 2 pi divided by 4, which is pi over 2. So there's an asymptote at pi over 2 and at negative pi over 2, and then 3 pi over 2 and negative 3 pi over 2. Then this is cosine. Cosine starts, or it's the opposite of cosine. Starts at 1. It starts at your fake amplitude or your amplitude. So we're going to draw a point right there at 1. And it's going to go up. Right there, that goes down, down, up. Okay. So the cosecant graph and the secant graph are very similar. It's just the secant graph is a little shifted and the cosecant graph is not. Okay. And then tangent. So this is our tangent graph. This one has asymptotes. The cotangent graph is the reciprocal of tangent. We still have asymptotes on this. So wherever tangent equals 0, there is an asymptote. So there's an asymptote right there, and I'm going to try and make those thicker so you can see. There's an asymptote right there at negative pi, at 2 pi, and at negative 2 pi. Now this time, so if you look at the tangent graph, you start low and you end high. The cotangent graph, you're going to start high and you're going to end low. So you start at your high point and you end low. So you start at positive infinity, end at negative infinity. So it's going to be that right there. So you really just are flipping the tangent graph. Okay, you'd graph it the same exact way, you just flip it. So that's that graph right there. So that just gives you a brief overview of what the cotangent graph looks like, the cosecant graph, and the secant graph looks like. The green graph is the cotangent graph. So if we graph this again, there's no amplitude, that's undefined. And then the period here is pi. And my asymptotes are at my period. So my asymptote is at pi, maybe. So you have one at 0, then you have one at pi, you have one at negative pi, you have one at 2 pi and negative 2 pi. Then you go halfway between your two asymptotes, draw that point right there. Draw one, go over one, up one to the left, over one, down one to the right, and it's that graph right there. And then that just repeats itself. So that's going to repeat right there, and repeat right there. Okay? So that's the basic gist of these. Let's get into actually graphing them. So if I have y equals 3 cosecant of theta, cosecant is the opposite of sine. And I would maybe write that. I don't think I did write that. So cosecant is the opposite of sine. Let's label our A and our B. My A is 3, my B is 1. B is always what's right in front of theta. My period here is 2 pi over my B value, which is 2 pi. Then the last thing I need to find is my asymptote. So the asymptote is the period divided by 2, which is 2 pi divided by 2, which is pi. Okay, for the cosecant graph, you always start with one asymptote at 0. Then I'm going to go over pi, draw that asymptote. I'm going to go to the left pi, draw that asymptote. At 2 pi and negative 2 pi, I have asymptotes. Okay, now my A value here was 3. So A is our fake amplitude. And instead of starting at 1, like I did on the original graph, like the graph on top, I'm going to start up at 3. And that's where my parabola starts, so I can just catch that right there. So that starts at 3, which means at 3 pi over 2, I'm going to start at negative 3, and that's going to go down right there. Okay, at negative pi over 2, I start at negative 3 and it goes down. At negative 3 pi over 2, I start at positive 3 and it goes up. Okay, so I just have my 4 little parabolas there. That continues to do that all the way to negative infinity and all the way to positive infinity. It just continues to have this upwards parabola, downwards, upwards, downwards. It just continues. Okay, now let's do secant graph. So I have y equals 1/2 secant of theta. So let's label our A, let's label our B. Our A is 1/2, our B is 1. My period is 2 pi over B, which is 2 pi over 1, and that's just 2 pi. Then to find my asymptotes, I take the period and I divide it by 4. So that's going to be 2 pi divided by 4, which is pi over 2. And then secant is the opposite of cosine, but the secant graph does not have an asymptote at 0. I would maybe write that down. There is not an asymptote at 0. So I'm going to go over pi over 2, draw an asymptote right there. Go over negative pi over 2, draw an asymptote right there. And then it's every interval of pi over 2. So at 3 pi over 2, there's an asymptote. Negative 3 pi over 2, there's an asymptote. And then again, A is the fake amplitude. So instead of starting at 1, like I did on the graph up top, I'm going to start at 1/2 because my A is 1/2. So 1/2 right there. Draw that upwards parabola. At pi, I'm going to go down 1/2, draw that downwards parabola. So that's downwards, and that one would be up. And you start at 1/2 at negative pi. You go to negative 1/2, you go down. At 2 pi, up 1/2, and you go up, upwards parabola. Okay, so the secant graph, you start at 0. And then the cosecant graph, you have an asymptote at 0, and you start halfway between the first asymptote and the second asymptote. Okay, let's get into cotangent now. So, again, always start with labeling your A and your B. So my A is 1, my B is 2. So to find my period, it's going to be pi over B, which in this case B is 2, so that's pi over 2. And my asymptote is my period, so that's going to be pi over 2. And then cotangent, you always start with an asymptote at 0. So I have an asymptote right there. Then I go over pi over 2. There's an asymptote. Negative pi over 2. There's an asymptote. Then just keep going. So there's 2 in between each of those. So we're gonna have asymptotes every 2 units, or every pi over 2 units. Okay. Then let's go halfway between 0 and pi over 2. And I'll draw our point right there. Then our a value is 1. This is cotangent, so I'm going to start high and low. So I go up 1, over a half, because you go halfway between there, and there's that first point. Go over a half, down 1, there's that point, and then we can draw that. So that tangent graph, or cotangent graph, just goes right along the asymptote. And then that just repeats throughout this whole graph right here. Okay? We're just going to do one more example of each of these. So if we have y equals 2 secant of theta. Secant is the opposite of cosine. Let's label our a and our b. A is 2, b is 1. My period here is 2 pi over 1, which is 2 pi. My asymptote is the period divided by 4, so that's going to be 2 pi divided by 4, which is pi over 2. Now, since secant is the opposite of cosine, cosine starts at your amplitude, secant is not going to have an asymptote at 0. We're going to go over pi over 2, draw our asymptote right there, go negative pi over 2, draw that asymptote, then at 3 pi over 2, and at negative 3 pi over 2. Okay, then we're going to go up to my a value. A is 2. We're going to draw that parabola up. Go to pi, because we're going to go halfway between pi halves and 3 pi halves, which is pi. Go down 2 and draw that parabola that's going down. So it just goes right along those asymptotes. Same there, and same there. Okay, cotangent. Again, let's label our a and our b. So a is 1/2, b is 1. The period is pi over 1, or pi over b. B is 1, so that's just pi. My asymptote is my period, and I always start with an asymptote at 0 for cotangent. So my asymptote's at every interval of pi. So at 0, then I'm going to go up pi, draw an asymptote, down pi, draw an asymptote, up 2 pi, draw an asymptote, down 2 pi, draw an asymptote. Oops. Then you go halfway between 0 and pi, that's pi halves. Draw our point right there. And this starts at the left, starts high, and then ends low. And my a value is 1, so I'm going to go halfway between 0 and pi halves and go up a half. Halfway between pi halves and pi and go down a half. And then draw that graph right there. It just follows those asymptotes. Those 3 points right there just give me a little rough sketch of what this is doing. Okay, and then that just repeats itself. And that's going to continue to repeat itself, clear to positive infinity and clear to negative infinity. Okay, last one. So cosecant, again, let's label our a is 1, our b is 4/3. So my period here is 2 pi divided by 4/3. When you divide by a fraction, that's the same thing as flipping that fraction and multiplying. So that's 2 pi times 3 over 4. Which is 6 pi over 4, which reduces to 3 pi over 2. Okay, then my asymptote for cosecant is the period divided by 2. So that's 3 pi over 2 divided by 2. Again, that's 3 pi over 2 divided by 2. You can flip that fraction. So that's 3 pi over 2 times 1/2, which is 3 pi over 4. So my asymptote's at 3 pi over 4. For cosecant, you always start with an asymptote at 0, then go over 3 pi over 4. There's that asymptote. Go left, negative 3 pi over 4. There's that asymptote. And then just continue to do that. Okay, whoops, went too far. Now, my a value is 1, so I'm going to go halfway between my first asymptote and my second asymptote. I'm going to go up 1, And that parabola is an upwards parabola that follows along those asymptotes. Halfway between 3 pi over 4 and 3 pi over 2, go down one, draw a downwards parabola. Then that just repeats itself like that. Okay, please come to class with questions. I know it might be a little bit confusing, but just come to class with questions. I'm going to go over this a little bit more then. And remember to take the quiz.